Hello guys, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. Mathematical Side Trips, our channel name. In this video, discussion will focus on construction of equations in one variable, in particular equations from identities. By the way, I am Napoleon A. Gaking Jr., a math teacher. In this series of videos, discussion will cover different types of equations, namely polynomial equations, which has been discussed in the preceding video. Letter B equations from identities, which will be the subject of the present video. That is the reason why it is highlighted. Then in future videos, we will be taking up equations involving square roots, cube roots, fourth roots, and involving equations involving absolute values. In our earlier video, we discussed construction of polynomial equations, and in this video, we consider identities involving a variable and show how to convert them into conditional equations. Identities are equations involving a variable or variables that is always true for all permissible values. That is, all the values in the domain of the equation. 3 earlier videos in this channel discussed construction of identities involving a variable or variables. The following are identities constructed in the manner that is taught in those videos. Okay, so here we have 3 identities A, B, and C, and identity A would be true except for -3/2 and 2. Identity B would be true for real numbers except 0 and 2, and identity C would be true for all real values except -3/2 and -9/5. Let's look at them again. Okay, here. Now, if we replace x in any one of its appearances with a specific permissible value, the equation is no longer an identity, but a conditional equation whose solution set contains the number that replaced x. For example, if in identity A, the numerator in the fraction x over x minus 2 is replaced with 4, then we get the conditional equation. Okay, so we have this equation. So notice that in the second fraction here, the numerator is now 4. It's no longer x because it is replaced by 4. And when this conditional equation is solved, we get 2x squared minus 5x minus 12, a quadratic, which is the product of 2x plus 3 and x minus 4, indicating that x equals 4 is a solution of this conditional equation. Similarly, if in identity B, the x in x minus 1 is replaced with 5, then we obtain the conditional equation x squared plus x minus 3 over x times x minus 2 minus 1 over x minus 2 minus x plus 1 over x equals 4 over x times x minus 2, which simplifies to x minus 5 equals 0, which indicates that x equals 5 is a solution to the conditional equation. And finally, if in identity C, the x in 12x is replaced with -2, we have the conditional equation 2x squared minus 6 in the numerator for the first fraction, because originally it was 12x plus 18. So 12 times negative 2 is negative 24, and then plus 18, that would be negative 6. So it's 2x squared minus 6. And when this conditional equation is solved, it reduces to the linear equation x plus 2 equals 0, which indicates again that x equals negative 2 is the solution to this conditional equation. Now, when x in one of its appearances is replaced with a particular value, say x equals r, we are in a sense arm twisting the identity to become a conditional equation which, when solved, gives x equal r as its solution or one of its solutions. That is all for now. We hope that watching this video was worth your while. We hope that you have learned something new, interesting, or useful. Please click that subscription button if you want to subscribe, and hit that notification bell for updates about upcoming videos. God bless.